Is this any rules for doing derivatives? I mean, if we want to find the second derivative, we have to find the first derivative first. Do we have product rule, quotient rule, chain rule, anything, or is it just a regular one? It is a chain rule. So we have the 5x minus 3 inside of sine x. So first we do the derivative of sine, which is cos. You keep the inside the same, and then multiply by the derivative of the inside. So we get 10 cos. And then the second derivative, we'd have the chain rule again. I'm going to multiply that 10 out in front. And derivative of cos is negative sine. Keep the inside the same. And then multiply by the derivative of the inside. Then write down the integral, working backwards. The integral would be, well, we would have a negative cos, 5x minus 3, and because there would be a chain rule where you multiply, and then don't forget the plus c. Any suggestions on this integral? Can we do it regularly? No.
Integration by parts.
No, integration by parts won't work out nice.
I mean, it will work, but it will take a long time.
No, it wouldn't actually work because you couldn't integrate back a part of it. But substitution, we do have a function inside of another one, and the derivative is x squared, which shows up in the front. So if I would rewrite my integral, I have the square root of u, and the x squared dx can get replaced by du over 3. Can bring that 1/3 out in front and change my square root to u to the half. Add 1 to the exponent and divide. Oops. And then substitute back. So a little bit of review of integration by substitution. Again, how do you recognize integration by substitution? Well, first of all, it's a little bit easy if you can see one function inside of another function. So in this case, can you see an x cubed minus 1 inside of the square root? That's giving you a hint that maybe you could use substitution. And the second part that would say you could use substitution is if you took the derivative of that inside, does it show up outside of that function? So the derivative of an x cubed function is an x squared function. We're not worried about the coefficients in front or the numbers. But since there's an x squared outside of the function, that seems to indicate a chain rule has happened, so then we can use substitution to solve for it.
Also, if all other options don't work.
If all other, yeah, if you try everything else and nothing works, except for substitution, then there's a good chance that substitution would be the one. However, that method sometimes takes a very long time. Try everything that doesn't work.
Try it.
It's really, really bad with adding two numbers. 2 plus 5. I'm going to try 33. Doesn't work. Okay. Take it off the list. How about 78? No, doesn't work. Until eventually you only have one number left.
Well, I don't think that would actually happen.
Okay. These ones are a little bit more difficult because you're working with the properties. You're told that the area under a curve f of x, even though we don't know what f of x is, from 0 to 3 is equal to 8. So we've got who knows what kind of curve it is. But apparently this area from 0 to 3 is equal to 8. And the question is, how do we find these other areas? So this is really checking to see if we remember all of the properties of integrals. One of the properties of integrals is if you're multiplying a function by a constant, that constant could come out in front. So if I bring that constant out in front, then I get 0 to 3 of f of x dx, which we were told is equal to 8. And so the area of A would just be 8. The answer to A would be 16 because the area from 0 to 3 is 8. Multiply by that 2 in front, and we get 16. Integral properties for adding two things. When you add two functions, you could do the integral of them separately. Well, this one I already know is 8. And this one is an easy integral. It would just be 2x from 0 to 3, which would be 6 minus 0. So we get a total area of 14. Now that's using the properties of integrals. We could also solve this question with an understanding of transformations. If you think about transformations, what would that do to your graph, adding 2 outside of it? It would be a vertical shift, moving your graph up 2 units. So I'm going to take the graph that I had here. No, wait for it. There we go. I'm going to move this part up 1, 2 units, this up 2 units, this 8 up 2 units. Can you see that that would shift it up 2 units? Can you see that that would make a rectangle added on the bottom? What's the area of that rectangle? 6. And so now, does it make sense that the area under the curve, when it's shifted up 2 units, becomes 14? So we could understand this using transformations, or we could use the properties of integrals to help us see that. If the integral from c to d of f of x minus 2 is still equal to 8, what are the values of c and d? Okay, what does this mean? This means that the graph is moved 2 units to the right. So we had our original function from 0 to 3 with an area of 8. And if you moved everything 2 units to the right, can you see that that area of 8 would get moved 2 units to the right? And so now c would equal 2 and d would equal 5.